Last week we talked about inductive reasoning. Who can remind me what inductive reasoning was? Logic based on what? Patterns. Okay? Deductive reasoning is logic that uses facts, rules, definitions, and properties. Okay, so we're going to come back to the law of detachment, but I have two different examples typed out below, A and B. What I'd like you to do, I want you to read them and then have a discussion with your elbow partner about which one, like, is A inductive or deductive? Is B inductive or deductive reasoning? Go ahead. Facts versus patterns.
I have to write my own.
All right. Josh, what did you and Jack think about A? So when I said talk to your elbow partner, you did not talk to your elbow partner? And why is it deductive?
Because, like, if the book is late, then it's going to be true no matter what it says a fact. That is gonna
Okay, this is a fact. Okay, now, Ethan, you and Aaron, did you talk? Excellent. What do you think about Tamika? And why? It's a pattern. It's not a fact that when she wears her jersey, then the team will win. But it's a pattern that she's found. It's almost like a little superstitious, right? I'm sure none of you have any patterns that you follow for your team. Okay. So, I want... You have a good one?
No. I'm thinking of it. Philly, stop talking. Yeah, please do this. Please stop. Agree.
Everyone stare at Philly.
You just don't listen to him.
I found it on Taylor.
Okay, let's talk about law of detachment. Okay. So, this is kind of a multi-parter here. The law of detachment. We have this general statement, if P, then Q. Then we have something specific. So this is like a general statement. Then we're going to get specific, okay? We're going to talk specifically about something happening to like a person or an item or whatever, okay? But if we have this statement, P implies Q, and we know something specific about P, then we can conclude that specific conclusion Q. feel like I'm talking in circles. What?
How does this relate to shapes? Like,
This is logic.
This isn't.
Math is logic also, not just shapes.
I love this.
All right, so next page. All right, so right now we're not even going to look at this right here, okay? Okay, so let's look at what we're given. To go on a field trip, a student must turn in the permission slip. Gosh, what is the if-then statement?
If a student turns in the permission slip, then
If
they
the
can go
student
on
goes on the
the
field trip, then they can use the permission slip.
I think that means why does it go on the field trip?
Okay, what do you have to do first?
If a student turns in the
Okay, if a student turns in a permission slip, then they can go on the field trip. Okay, so since it wasn't an if-then statement, I went ahead and rewrote it so we can clearly identify our P implies Q. Okay, I'll let you catch up. All right, so I would say a student turning in a permission slip, that's P. Do you agree?
Yeah.
And then they can go on the field trip is Q. Okay, so we all agree. So then now we have a P implies Q. We have a specific statement. Mariana turned in her permission slip. That is specifically P or Q? P. So we have something specific about P. So P implies Q, P is true. So if Mariana turned in her permission slip, what does that mean? Okay, so this is a valid conclusion. See how that works? Okay. Only sort of. So let's look at this one. And oh, how nice of me. I put it in an if-then statement already. If it is a square, then it is a polygon. All right, so I'm going to use my, if a figure is a square, then it is a polygon. Figure A is a polygon. Can we conclude, oh, what, why?
It's not all polygons are squares.
Okay, other than that, using the law of detachment, why did Philly go, meh?
Because Philly's weird like that.
Because he's theatrical. Because he is literally Einstein.
Ah, the statement is Q. All right, we have P implies Q, which means when we get specific about figure A statement needs to be about P. Is this P?
No.
No, it's Q, so this is invalid.
Oh yeah.
Okay, if I ask you, hey, what is the conclusion? You would say there is none because it doesn't work. Okay, so how about you decide if example C is valid or invalid with the law of detachment? Kelly, what do you think? Is this valid? Okay. If P, then Q is Dakota going to the video store this afternoon. Does that match P?
Yeah.
And this matches Q? Okay, excellent. Ooh, that's a fun smiley face. All right, next page. The law of syllogism. I know. Okay, this is called the law of syllogism, and it's actually what you did in your introduction activity.
Philly, can you say that?
Syllogism. Okay? This is what you worked with in your warm-up activity. If P implies Q and Q implies R are both true. That's what I just said, dude. What am I going to write next? Then imply, not equals, implies. Well, when we're talking about equality.
Oh my god.
So, yeah, this feels a lot like, hey, you guys can maybe hold hands in the hallway, but not in here. Okay. Got it. Okay. Okay. So, we have a nice little sandwich of logic statements where the conclusion of the second needs to match, no. The conclusion of the first needs to match the hypothesis of the second, and then we can go from first to last, okay? So let's look at this example 3A here. And I really like to color code. I know that you have a pencil, so maybe some like different squiggles would be good. So if you do not get enough sleep, then you will be tired. Okay? There are my two statements. If you are tired, then you will not do well on your test. Okay, so do you notice how I gave the same squiggles under the statements that matched? Okay, so do we have P implies Q and Q implies R? Yes. So what we can write is if you do not get enough sleep, then you will not do well on your test. Okay, I'm gonna give you 2 minutes to look at examples B and C and see what you can come up with. It does not have to be individual. You can work with your elbow partner or as a table. B and C, please. So, lost syllogism, you're out the new statement. Sorry, dude.
Imagine if this, but there's no if then statement. We can copy and paste this kind of.
So basically, if figures and rectangles are all
This is what happens.
No, I don't.
The figure is a rectangle, then all interior angles are 90 degrees. But isn't that true? If the figure is a rectangle, all the interior angles are 90 degrees.
I don't know why you have like that.
Me too. Actually, I'm kind
What? Come on.
They all have coordinates.
No, these are the same.
All right, let's talk about these. Charles, did you write a statement? Hey, I think I'm talking. Thanks. Did you write a statement in B? What did you write?
You can eat days of vacation, then to the car.
Did you also write this? Okay. It is in the right order. This is good. Now, I'm going to color code this. If a figure is a rectangle, then all interior angles are 90. If a figure is a square, then all interior angles are 90. What do you notice? It's not in the right order. So we can't do it.
That one is
Plus, if you tried to make it work, if you go left, right, the figure is square.
Doesn't work. Okay. Yes, these two, are you saying these two would need to be switched if we wanted to be able to write something?
Are you not allowed to?
No, I meant to switch rectangles.
Okay, that was a good question. I was asked if, can you rewrite it? These statements are rewritten as is. The only time you can rewrite if it's not in if-then form, then you probably should write it in if-then form, you know, like we did over here. Otherwise, don't rewrite it. Okay?